A point source microscope is a digital version of a classic autostigmatic microscope commonly used for over a century to measure the radius of curvature of concave mirrors. This picture, from a paper by W. H. Steele, shows the basic details of an autostigmatic microscope. Illuminated crosshairs are imaged on a surface at the microscope objective focus. These crosshairs are re-imaged at the focal plane of the microscope eyepiece. As Steele pointed out, there is a close similarity of an autostigmatic microscope to an autocollimator. An autostigmatic microscope has a finite focus, while an autocollimator focuses at infinity. Otherwise, they are identical. This schematic diagram shows a simplified ray path through a point source microscope where the internal light path is collimated, so that the PSM is an autocollimator when the objective is removed. Other than the internal collimated light path, the PSM is optically identical to either a classic autostigmatic microscope or an autocollimator. Here is a look inside a PSM to show why it is a digital version of an autostigmatic microscope. Instead of crosshairs, a pinhole light source is created by a single-mode fiber coupled to a laser diode. This source is collimated and directed into the microscope objective. The objective focuses the light to a diffraction-limited point that expands into a nearly perfect spherical wavefront. The light reflected back into the microscope is focused onto a CCD camera and viewed on a computer display. The centroid of an in-focus spot is monitored in real time to less than a micron laterally. Initial setup of the PSM is easy because the brighter laser source is visible under ambient lighting. The laser intensity is reduced as the microscope is brought to best focus, where the spot is a minimum size to avoid saturation. Following the light through the PSM, there is a single-mode fiber termination of the laser diode. This is followed by a fold mirror and collimating lens. A first beam splitter introduces light from a diffuse LED source, so the PSM can also be used as a digital reflecting microscope. A second beam splitter sends light out through the objective. Reflected light returns through the objective and beam splitter toward the camera. There is a filter holder if it is desired to filter the light, and a tube lens to focus the light on a digital camera. Both light sources and their electronics are internal to the PSM. The only external connections are for power for the light sources and USB 3 for video. Following this introduction to the PSM, please proceed to view our video, Use of the PSM for Alignment.